All right, in lesson 5.4, we're going to be looking at multiple angle identities. So identities involving double angle, half angle, and power reducing formulas. So in this video, we're going to look specifically at the double angle formulas for sine, cosine, and tangent. And we're going to start with an example, and we're going to start with a proof. So we're going to prove the double angle identity for sine, that sine of 2u equals 2 sine u times cosine u. So we know with proofs, we have to start on the side, or pick a side. We're going to start, in this case, on the left side. And what I'm going to do is I'm going to rewrite my angle here, 2u, as the sum of two angles. So instead of sine of 2u, I'm going to write it as sine of u plus u. U plus u is 2u, and the right side remains unchanged. So our goal here with this proof is to turn the left side into the right side. So we know from lesson 5.3, there is a formula for the sum of two angles for a sine function, right? So we know that sine of a plus b is sine, cosine, cosine, sine, right? It's sine of a times cosine of b plus cosine of a times the sine of b. So I'm going to use that here. So it's going to be sine of u, cosine of u. Sine keeps the sign, so plus cosine of u times the sine of u, and the right side remains unchanged. All right, now notice here we have sine u, cosine u, we have cosine u times sine u. Those are the same terms, right? I can rearrange the terms here in this product, and we know that multiplication is commutative, so the order doesn't matter. So I can rewrite my left side as sine u, cosine u, plus sine u, cosine u. And the right side remains unchanged. Now, since these are the same terms, I can combine these like terms to create 2 sine of u times the cosine of u, and that is exactly what is on the right side. So we have proven the double angle formula for sine. All right, example number 2. We want to prove that the cosine to the fourth of theta minus sine to the fourth of theta equals cosine 2 theta. All right, so we have a double angle expression on the right side, but in this case, we're still going to work on the left side, actually. So I'm going to start on the left. And what I notice here is that I have something to the fourth minus something to the fourth. That reminds me a lot of a difference of squares. Like if I had x to the fourth minus y to the fourth, I could factor that as x squared minus y squared times x squared plus y squared. So I'm going to do that here. So I'm going to factor cosine to the fourth minus sine to the fourth as cosine squared theta minus sine squared theta times cosine squared theta plus sine squared theta. And the right side remains unchanged. Well, lucky for us, right? We know cosine squared plus sine squared is one of our Pythagorean identities. That expression is equal to 1. So this becomes cosine squared theta minus sine squared theta. And this second factor is all equal to 1. And so then now we have cosine squared minus sine squared. Well, if we look up here, that is one of our double angle identities. So we can actually use that here in this proof. So this is going to be cosine of 2 theta times 1 equals cosine of 2 theta. And that is exactly what we have on the right side. So we have proved this identity.